Well, thanks, everybody. Thanks for letting me come and crash your party. This is actually, I was telling them, this is my first live conference talk since before the pandemic. So I'm pretty excited to be back. I've been doing a lot of this in my basement on video, a lot of which I get to actually pause and hit, rewind and redo. So if I mess this up, please, give a little grace. And the truth is, I wasn't meant to be here, I don't think. You'll see up there the 4 PRs that I've contributed to PowerShell. You'll notice a lot of them have to do with Unix and a little bit of Mac OS and some Ubuntu derivative work that I did when I ran into some problems. I've been a lifelong Bash user. In fact, I tried to convince Steve to lowercase all of PowerShell. He said no. He said maybe I could do it in my own fork. But so that's just my way of saying that I'm really actually very appreciative of your taking the time to welcome me into this community and to hopefully listen to some things that are useful. The truth is that despite the fact that I'm not sure I was meant to be here, I'm actually really excited to be here. And part of the reason that I'm so excited to be here is that I see in this community and I see in PowerShell a ton of the things that personally drew me into technology and drew me into what became known as DevOps and all of this sort of thing in the first place. There's this component of open source software that I've been doing for a very, very long time. And just honestly hearing all him being like, I'm the only guy here and I have kids, and could you please help me run this website for me? I feel you, right? This is open source in a nutshell, this bringing of the community together. And we'll talk a little bit more at the end of the talk about what you can do. It's easier to get involved than you think, perhaps a little less intimidating than you think. But that current of community and that current of coming together as a group, represented by the people in this room, but also represented by all of the people who are out on GitHub, is something that draws me into this field, right? It's kind of a lonely thing to be doing it only in your basement by yourself, and being able to have all of these people come and sort of support you all the way through is an amazing thing. I'm also very much about empowerment, it turns out. The Microsoft mission of empowering everybody in the planet to do more is something that personally resonates with me. And when I look out into PowerShell and when I look out into the broader sort of DevOps community, I actually genuinely believe that that's what we're doing, right? I remember back in the day when I would wake up at midnight or 1 a.m. to upgrade a server, which involved SSHing into a machine, literally killing a process and hoping nobody noticed, and restarting the new process, right? And we've come a very, very, very long way, and it's because we are thinking about how do we make sure that people who are responsible for doing this kind of stuff don't have to wake up in the middle of the night, don't have to miss kids' soccer games or miss a performance that they want to go to or whatever else it happens to do, because we're working our way through automation, through reliability, and through all of the things that I think motivate us to be involved in this particular community. And then also I think the part of it that comes together in the teaching, right? And that's the third thing I think that really resonates for me as well. I actually was a teacher in a previous life, and I like to think that some of this speaking is actually continuing that inspiration of teaching. And I love the fact that we come together to teach others and to help others and to build useful things for others. That's another thing that I think in this community I see and in general resonates with my experience within the technical community as well. And so for all of those reasons, I'm super excited to be here. I'm also super excited to be under the lights and be out in public talking, and that's pretty awesome as well. So it's very, very awesome to be here. I wanted to start a little bit with my story and maybe talk through some of the stuff that I think is interesting. I was actually, as I mentioned, I was a professor for a few years. I got a PhD in robotics. I kind of been all over the place and doing a lot of what I fell into and doing DevOps and doing server and distributed systems for the last decade, actually almost close to 2 decades at this point. really was not the plan. And so I think it's interesting to take a look back and see why and what happened. What happened that made me be so interested. And hopefully this gives you some illustration of like how you too, maybe it resonates with some of your path, maybe it gives you some ideas for new paths. But the very first thing that happened, I mentioned this earlier, was open source, right? I got started in open source because I was actually one of the IT people in the campus, I guess it was the computer lab is what we called it. I had a pretty old laptop that didn't really do much. I was really interested in learning more about how you administer these servers and administer these sorts of things. And the person who ran the IT lab was like, well, we have this pile of broken old computers over here. Feel free to rummage through the dumpster if you want to go rummage through the dumpster. And I rummaged through the dumpster and I found a Mac, a 68,000 Mac, if anyone remembers the Motorola 68,000. And I was like, great, this thing runs Mac OS 8. No, it wasn't even 8, it was like 6 or something like that. It was old even at the time. But what I discovered was that there was an open source community around NetBSD. NetBSD is a derivative of Berkeley BSD. There was a community out there on the mailing lists doing random stuff. For some reason, they got it in their heads that they should figure out how to run this operating system on this piece of hardware that was truly ancient. And that was the first sort of like true computer that I had to administer. And along that way, I got involved in all of the mailing lists. There was no Stack Overflow. There was a little bit of IRC. I got involved in all of the sorts of things that I think we all sort of find ourselves coming into in these communities, which is throwing ourselves out into the void and hoping that somebody's going to catch us, hoping that somebody's going to be there to be like, oh, okay, yeah, we'll help you with that weird problem or that particular keyboard that doesn't work or whatever it happened to be. And through that experience, through both figuring out how to actually run this computer, but also getting connected with how you learn in this worldwide community was something that truly powered me along. I think the next thing that happened along the way, and I agree, I think this hopefully is something that people are excited about, was this idea of impact at scale. The ability to do something, touch a particular script or a particular program and distribute it out to hundreds or thousands of machines. Right? That sense of going from that one machine that happened to be running in my dorm room to committing a PR. Well, it wasn't called a PR at the time. It was actually using, oh God, I can't even remember what kind of version control we were using. It was some sort of pre-Git version control. Being able to have code go out and go into the world and connect to a whole bunch of other people and solve problems for other people was something as well that really sort of motivated me to get more involved. And I talked about this as well at length, so I think I'm going to skip over it. But this was something else that finally, as I sort of left from learning and started actually teaching, and that graduation from being the person throwing myself out onto a mailing list to being the person who is answering people's questions out on the mailing list was a pretty powerful transition and an exciting moment that has sort of driven me through the rest of my career. So what have I learned along that way? One of the things that I mentioned is the very first thing, and I think this drives a lot of what we've done, what you have done. I get a little nervous every once in a while because I'm ascribing to you things that I assume you have done, but maybe I don't know. Is the first thing I remember thinking about was automation. Right? Was how do I go? And a lot of this was done within my PhD actually, where you run a bunch of experiments. And in grad school, you really don't necessarily want to be spending all of your time in the computer lab. But if an experiment runs for an hour and you need to get the results and you need to do a little bit of processing on the results, and then you need to run another experiment, and you need to do this over and over again, you kind of end up getting stuck. And the first thing that I sort of started thinking about there, and the first places where I started to learn how to do scripting, was to say, how do I automate this? How do I get to my softball game and let my experiments run all night? How can I make sure that if something fails in the middle, because the first time you do that, you write all the scripts, and it fails on like the second command, and you come in the next morning, and your data files are not there, and you're very disappointed. And you start learning, okay, like as I start doing this automation, how do I make sure that it gets restarted if it fails? Or how do I make sure that I detect a problem before it occurs, delete the directories before I try and recreate the directories again? But that path down towards automation so that I can start thinking about doing other things than just sitting and waiting for an hour, pressing enter, and sitting and waiting for an hour, pressing enter again. That's, I think, one of the first steps down this road into hopefully what you're all doing at this point with PowerShell and beyond. I think once you start doing that, once you start thinking about automation, the next thing that we start thinking about is parameterization. So when we think about parameterization, what I started thinking about was, oh, okay, I'm going to run, I have a bunch of different experiments that I need to run. And instead, I think like all of us, I started out with a script called experiment 1, and then I started out with another script called experiment 2, and another script called experiment 3, experiment 4, and so on. And eventually you start realizing that you're cutting and pasting the same instructions throughout all of these sorts of scripts. And actually you're doing a bad job of it because you'll fix a problem over here, but you'll forget to cut and paste the solution into the other scripts that you've run. And eventually you start saying, oh, okay, like I can actually take chunks of what I'm writing, pull it out, turn it into something that's reusable, turn it into something that's useful. But in order to make it truly useful for a variety of different things, I need to parameterize it. I need to start thinking about how do I go from just automating stuff to how do I go to something that I can call into. And I can choose how long am I going to wait, or what is the particular program that I'm going to run. And that's sort of the next step, I think, in this journey that we've gone through from typing to automation to libraries and automation, libraries and parameterization. The next thing that I think became really apparent as I started talking to some of the people who were in the lab with me or in other environments was the idea of sharing this stuff. So that when you start thinking about, hey, I built all of this stuff for myself, it's very useful for my environment, then suddenly you start saying, well, actually, it probably could be useful for other people's environments. It probably could be useful for, so he mentioned you're not as unique as, the particular problem that you solved is not something that is unique to you. And I think that's true, right? The fact is that we run into a lot of the same problems all over and over again, and we're better if we come together and we share solutions to those problems as a broader community. But in order to do that, sharing is always tricky. And the reason that sharing is tricky is twofold. First of all, you're on the hook to a certain degree, right? When you share out a script with somebody and it happens to delete their entire hard drive, they don't think, well, geez, that was my fault for trusting you. They kind of are upset with you, right? And they probably should be, right? So the very act of sharing takes on a little bit of risk for ourselves. It also takes on a little bit of obligation for ourselves, fixing problems when they occur. It takes anticipating problems that or differences that might occur. I've shared so many scripts that it turns out had my own home directory hard-coded in it somewhere, right? But you don't never notice, right? Until you take that script to a different environment, you never notice that your username was in there somewhere. And so that act of sharing, and then also if you really truly are interested in sharing and you're motivated to share, there's also all of the work that was mentioned that hopefully you're going to be doing on, I think it was Wednesday, around documentation. Because sharing is useless if people can't figure out how to use what you've shared. And so that not only is there taking on some obligation around making sure that it's a good thing and you fix it and you keep it up to date and you keep it alive, but then there's also the obligation of I don't know if it's an obligation, but if you want to do a good job of sharing, there's a need to document it. There's a need to make sure that other people can discover what you're doing. And at the end of the day, all of this sharing is, I'm not going to say it's a selfless thing because hopefully you get some stuff from other people on the other side. But it's an act of generosity, right? And it is an act that produces the community and produces ultimately the value of these communities, which is that together we can do more than if we did it individually. I think also one of the great things I've personally found about sharing is you get to see how other people solve problems. And I'm particularly excited sometimes when I discover solutions to problems that other people have come up with that never would have even occurred to me. And that's a pretty awesome part of sharing as well, that I get to go and see how other people have gone and done things. Once we think about the next piece of this, I think, that I discovered along the way was when I stepped into cloud computing. So a little over a decade ago, I switched from working on web search infrastructure to working on cloud computing. And in working on cloud computing, I started to build what was a deployment system, a system that was oriented around, going and taking an instruction. I want to deploy, Nginx, or I want to deploy WordPress, or I want to deploy whatever it happens to be, and building something where it was effectively a button that a person could press. If you're familiar with ARM templates, it was that sort of an engine. And what you rapidly discover when you build this kind of automation that is no longer something that you run on a computer that you're logged into, or you run as part of a initialization routine, but rather something that is being run concurrently by thousands of people around the world, thousands or more times every single day, is you learn two things. One, the internet is a very, very unforgiving place that fails all the time. And the second is that every single possible instruction that you ever put into a script that could fail will fail, right? And it's remarkable, honestly, because I had been, by the time I started working on this deployment engine, I'd been scripting and thinking about automation for a pretty long time. And we walked into these systems, and you build something that runs and installs all the packages and configures all the files and does that whole thing. Works great. You've been developing it for a week or 2 weeks or however long it is. So you've run it a bunch of times, and you know that it works. And maybe you've hit a couple failure cases, and you put some if-elses and some retry in places. You put it into automation. You run it. We put it into automation, started running it. Our success rate, I'd say, was roughly 80%. Of the deployments we pushed out, 80% of them worked. And none of them, it would always be stuff like, oh, actually, a great example would be we triggered DDoS protection in the package server that we were talking to, right? So suddenly, you've been running this script iteratively over and over and over again on your machine, deploying one at a time. You put it out into the wild. It does 1,000 of these things in parallel. It's pretty hard for a package server to tell the difference between you turning up 1,000 machine Nginx replicated web server and a DDoS attack. And so what we would see is and it's flaky because sometimes, timing-wise, you wouldn't quite hit their thresholds. But every once in a while, a big chunk of our deploys would fail because the package server would just start rejecting us, or it starts throttling you. Or it happens to be the case that they are the ones who are logging in and killing a process and restarting a process right at the moment when you happen to be doing the deployment. And so what we did as we started doing into this is we got very, very, very focused on this idea of idempotency. I don't know how many people have heard or thought about idempotency before, but the idea behind idempotency is that you can simply rerun the script over and over and over again. If you look at something like containers and container images, which Docker popularized, roughly a decade ago, this is one of their primary value propositions. One of their primary value propositions is that you can reinstall a container image as many times as you want, and it will always do exactly the same thing. But it isn't a property that's restricted only to container images. It can be something that we bring to our scripts, and frankly, it can be something that we bring to everything that we do. It's a core principle within the Azure Resource Manager APIs that we use for creating things inside of Azure. And the idea is that effectively, if I know that something is idempotent, if I know that if I just keep applying it over and over and over again, it will continue to work correctly, and it will eventually get to the right place, then it's relatively easy for me to introduce reliability simply by reapplying the same thing until it succeeds. A canonical example of a failure mode for idempotency that I have personally implemented many, many times is something like a script that creates a directory and then populates a bunch of files within that directory. That works great the first time you run that script. But the second time you try, if it fails somewhere down below and you try and run that script again, it tries to make that directory again, And one of two things likely happens. First of all, either an error occurs because the directory already exists and you haven't done the right thing to say create directory only if it doesn't exist, or you create a directory of the same name within the other directory. Neither of these obviously are very good outcomes, and it causes your script to fail. And it's a really horrible situation where like you're 3/4 of the way through the script, some particular line fails, you run the script again, it fails like way earlier where it had succeeded before, and suddenly you're like, this isn't very fun. And that idea of being able to create automation that is idempotent, that does exactly the same thing every single time you do it, no matter how many times you do it, really, really simplifies. It adds a lot of clarity to the goals because you can test it, right? I don't have to run it 1,000 times in order to figure out if I'm flaky. I can actually just run it myself a bunch of times and see if it does itself over and over and over again. And then once I get to that point where I know that I can rerun this script over and over and over again as many times as I want until it succeeds, then I just put it in a loop that basically says, like, while not succeeded, run my script, done. Right? And now I've actually gotten to a place where I'm at 100% reliability no matter what. Right? And I don't have to figure out, oh, I'm going to go put retry around that particular URL, or I'm going to have to go and put whatever other kind of error checking in any place. It doesn't really matter, actually. Right? Because I just start from the beginning every single time and go through it. Now, admittedly, sometimes you may want to short circuit some things, right? Especially if you're doing things like long downloads or other sorts of things that take a lot of time. The naive approach to idempotency can actually introduce a ton of latency. And so after we'd gotten to the place where this deployment system deployed everything reliably, suddenly people started saying things like, well, every once in a while it takes an hour to deploy this thing when normally it takes 5 minutes. And at that point you go, oh, okay, like it's stuck in some loop, retrying over and over again, running this idempotent script over and over again, downloading things over and over again. And you go in and you push in some optimization, but it's a second order thing, right? It's always easier to get correct first and optimize second than it is to try and build something that's optimal but flaky and then try and make that optimal but flaky complicated thing be reliable. Right? So hopefully this idea of idempotency is something, maybe you've seen it before, definitely something that you want to be headed down towards in all of the different scripting that you do and all of the different automation that you do. I think the next step that we sort of moved towards, after we got finished with idempotency, the next step that we sort of moved towards was this idea of declarative. This is an example of declarative state config. But I've spent a lot of time in XML, in JSON, in YAML, in I don't know what the next declarative language will. I mean, we're working on Bicep. There's a bunch of interesting declarative languages out there. The idea behind a declarative language is that instead of me writing something that I can run that is hopefully idempotent so that I can do it over and over and over again until it's fixed, is I actually just write ahead of time where I want to be. In some sense, it's as if I wanted to say, this is what the world should look like, and then some other system takes on the task of making it be that way. Right? So instead of having to give you all of the instructions that say, hey, you know what, I would like you to do this, and then do that, and then do this, and then do that, it's as if I said, you know what, I'd just like my house to be blue, and somehow, probably through the magic of hiring painters, my house turns blue, right? But from my perspective, as the person who was not actually responsible for running the paintbrush across the house, I simply said my house should be blue. And I think that move from imperatively describing everything to declaratively defining everything is actually a really important one. Not so much for the reliability that it provides, because actually, a really well-written idempotent script can be quite reliable. But I think actually because it captures more of the intent. It's easier to understand a declaration than it is to understand a sequence of instructions, right? It's much, much easier to if I described in free text the act of painting my house, it would take you a lot longer to figure out what was going on than if I said my house is blue, right? There's a difference in sort of our ability to parse the document. And why that's important, actually, has to do with change management. And thinking about how we actually make changes to our systems. So everything that I've talked about so far, I think, has had to do with simply doing something on the system. But the systems that we maintain and the systems that we operate, they're not systems that just sort of come into existence and then stay. They're systems that come into existence and then change. Whether it's a weekly software rollout or a security patch or whatever else it happens to be, we're constantly changing these systems. And shockingly enough, when we change these systems, they oftentimes break. And as a result, and we want to have a deep understanding of what changed. And because a declaration, when you change the declaration, it very crisply describes what changed in the system, it's very easy, or hopefully easier, to understand what changed in the system. And it is also easier to understand what is going to change in the system, which brings in the other really valuable part of these declarative configurations, I think, which is that they are oftentimes implemented as a piece of code that is checked into a repository and some sort of automation that takes that code and turns it into the actual outcome. This is sort of the CI/CD thing, continuous integration, continuous deployment, that happened a little over a decade ago, right? This idea of infrastructure as code. And the reason that's really important is because instead of changing the world being something that happens when I run something, changing the world becomes something that happens when I check something in. And the net result of that is that I can actually apply many of the things that we've learned how to do in software development to the act of modifying my own environment. And in particular, I would highlight that we can do two things. One is code review, and the other is linting and testing, right? So if you're going to, run a script, you could buddy up and you could say to somebody, hey, I'm going to go run this script, or you could be following along a web page. But it's easy to make mistakes. It's easy to say, forget about a particular thing that might happen. If we think about doing infrastructure as code through declarative configuration, I send a change to the source control system. Somebody has to review that change. Because it's declarative, it's relatively easy to see what is changing. Because it's happening in version control with automation, I can actually unit test that change. I can sanity test that change. I can ensure to the best of my ability that the change makes sense, all before that particular piece of code gets checked into a repository and applied out to my environment. And so this switch to declarative configuration, it provides a great deal of benefit beyond simply the reliability of the execution of that declarative configuration because of the things that it enables adjacent to it, because of the processes that it empowers, because of the human interactions that it lights up, and not to mention also the readability of bringing someone new into the system so that they can understand what's going on in the world today and how can I make changes to that world going forward. So I've spent the last decade probably trying to convince everybody that declarative configuration is really the only way they should be thinking about running their systems. But I wanted to actually take a step forward from there into the next part, what I think is an even more interesting way to think about running our systems. And we're starting to see the shape of this sort of thing happening. The analogy, or the story that I'd like to tell that maybe gives you a motivation for this style of management for our systems is a story from my childhood, where I don't know how many people have built balsa wood airplanes. But I built a balsa wood airplane. It's a very exacting process where you cut out lots of these pieces of wood and you glue them together and you put paper over to form the skin of the airplane and all those sorts of things. And this particular one was a remote controlled airplane. And it took me, 2, 3, 4 months to build this particular airplane. Finally, days come, it's ready to go. I've tested the propellers, all this sort of thing, bring it to the airstrip, light up the propellers. It flies into the air. Dramatic achievement, music swells, and it crashes and explodes into a billion pieces about 10 seconds later. It was a little heartbreaking. I'm not going to lie. my mother actually said it was the most helpless feeling she'd ever had. So that's what I did. That's what I did for her, because she was like, she had no idea how to make this thing work. I want to contrast that to a little while ago when I can't remember exactly when it was, a birthday or Christmas or maybe just, Amazon delivery day. My children were handed a quadcopter drone, fired up the iPad, and they're flying the thing around the house, right? Why are they flying it around the house? It's not because they're better pilots than I am. It's better pilots than I was when I was a 10-year-old kid. It's because they're not actually controlling the quadcopter. They're giving the quadcopter intent. I would like it to go up. I would like it to go forward. I would like it to go left or right or whatever it happens to be. And the piece of software that's running on that quadcopter is translating that intent into varying speeds on these 4 propellers that are electric motors at the end of the day. And varying speeds on those electric motors will implement the intent of the user, right? So by switching from analog input of throttle and flaps and all of that sort of thing to intent-based input, go forward, go back, go left, go right, and inserting intelligence, or at least inserting automation in between my intent and the execution, dramatically simplified the problem and made it possible for, straight out of the box with no experience, someone to fly this thing around the house. Right? And I think that's the real power of intent-based. We talked about declarative, and of course, you can't have intent-based stuff without declarative stuff. But the thing that intent-based stuff allows you to do is actually say, let me actually move beyond the literal. Let me move beyond the specific. And let me actually up-level to something abstract, right? You could say something like, I would like a website running with 250 milliseconds latency to every user in the world, around the world, right? That's an intent. Now, that's going to get manifested into a number of servers at a particular time. Maybe it's going to grow. Maybe it's going to shrink. And when we look at systems like auto-scaling and we look at systems that do automatic health-based restart and all that sort of thing, we're starting to see the shape of these intent-based systems coming together. Now, what's particularly interesting as we sort of walk down this path, I think, towards intent-based systems is the interplay between where the automation comes in and where the human comes in. Take an example like auto-scaling. It's pretty clear that the automation comes in to make this thing bigger and make this thing smaller, but I've actually seen real problems occur, real outages occur when the human updates a configuration and leaves within it the scale, right? You may have said like, hey, checked into my declarative infrastructure as code, I've checked in 2 replicas. But actually, somewhere else, there's an auto-scaling system that's been manipulating that 2 replicas for a while, and you're under heavy load right now, and so maybe it's at 100 replicas. But because you want to change some other flag, or you want to move a version forward, or whatever it happens to be, you check in a new configuration that still has that 2 replicas in it, even though you've delegated control of the 2 replicas over to the autoscaler. And when that thing deploys, you suddenly scale yourself down from 100 replicas down to 2 replicas because you've pushed a new declarative state into the system, right? And so living in a world where we have both automation and human changes sort of coexisting in the same environment is actually still a fairly complicated thing that we're still, I think, trying to figure out how do we say in elegant ways, like, these are the pieces that I'm still responsible for, and these are the pieces that I've delegated over to automation. And that leads us, I think, to the next part of the place, which is, I think, the most experimental and the most, really we don't know necessarily what we're doing. But this is the frontier that we've just started entering into, right? Which is actually giving over more to the automation, more than just, hey, could you keep my server running at the right scale? But actually starting to say, hey, you know what? Maybe via Copilot, I just actually say, I'd like a reliable website. And it figures out what a reliable website should look like. I think that's we're starting to see, as we've done these experiments, I don't know, actually, just out of curiosity, how many people have played around with like GitHub Copilot? A few people? All right. I would definitely recommend checking it out. It's very, very interesting. I'm not sure that it's perfect, but I think that it represents a significant step forward that we're going to see happening over the next 5 years. And I think that what it really, I think, allows us to do is start saying, you know what, let's take advantage of those best practices that are out there and the community of experience that is out there, not just based on like cutting and pasting from Stack Overflow or building parameterized libraries, but actually enabling us to go from that intent to a declaration in a way that doesn't require that we necessarily learn all of the details. But actually some of the areas that I'm even more excited about in terms of generative AI have actually to do with what happens after the system is running. So I've talked a lot about how you get a system to a running state. I don't know how many people here are on call. I've been on call for most of the last 20 years, along with deploying everything. And one of the worst parts of on-call is trying to figure out what the heck is happening at 3 a.m. when the alert's fired. The alert's fired, it's very obvious what the problem is. It's just never really very clear why. And I think one of the most interesting things that we've been sort of experimenting with, and I would encourage other people to think about and experiment with, is that sort of summarization ability of these large language models. All right, so it's great that they can generate declarative config for you. It's even better if they can generate a summary of your environment. Hey, I noticed that this server over here happened to be failing. Hey, it looks like you've got a cascading failure over here where this started to fail, and then all of these other servers started to go down afterwards as you lost capacity. I'm especially excited about that ability to quickly and crisply describe to us the ways that our environments are shaped. Because I think the other thing that I've noticed in all of these years of doing operations is almost always the problem is blindingly obvious in hindsight, but very, very challenging to find in the moment. Because I think we have, whatever it is, we bring our own blindered view onto the particular problem, and I think having that co-pilot around, having that other person who's there to suggest, well, maybe it's something over here. Hey, I noticed that there's something over here, I think is going to add a diversity of thought and a diversity of perspective to that ops and on-call experience that I think is going to be a really, really valuable thing. So as you go down the road, experiment with Copilot, experiment with generating your text for you, but think even more about how you can generate summarization for you and how you can better understand what you're doing. Or even, I haven't tried this myself, but even maybe that legacy script that's been sitting on that machine for 5 years and you don't know exactly what it's supposed to be doing or how it's doing it. Think about how we can use these tools, not just to create new stuff, but actually to create better understanding of the things that we have. And with that, I want to just sort of talk a little bit about where I think we are going. Checking on my time. I wanted to talk a little bit about where we are going and my own thoughts. I mentioned at the beginning that I was sort of, that it was a little bit, I felt a little bit like a fish out of water coming into this conference. But I think it's a really good thing, actually. Because I think one of the things that I look out and into the world and I see where we're going, I see the ecosystem converging, right? I see the world where we're no longer desktop admins or server admins. We're no longer Windows admins or Linux admins. For a variety of different reasons, these worlds are converging. And partially it's because the code itself is converging. Right? There is no such thing as a client-server application anymore. The application is on all of the devices, whether it's the mobile device connected to an API in a web server, sharing a screen with a desktop device, whether it's thinking about how actually do we do these large language models in a world where I want to have data privacy and I'd rather not be shipping all of my data into a large language model in the cloud. All of these things are going to mean that these ecosystems are simply coming together. And when we look at containerization, which is a very developer-focused idea that kind of abstracts away the specific details of what the operating system is, or we look at technologies like WebAssembly, which are explicitly building virtual machines that can run anywhere from the browser to embedded devices to up in the cloud, the ecosystems are converging. And so I think that it's not the case in 10 years that we're going to be thinking about ourselves as being, in the open source DevOps world or the PowerShell world or whatever it happens to be. I think it's really, and I see this happening, we're coming up on Build in a few weeks. I see this happening in the Build conference every single time I go, right? What used to be very .NET and Windows-centric is now becoming, cloud-centric and polyglot. And I think it's really, really valuable because of that. The community is stronger when all of these different voices are together. And of course, PowerShell has been along this journey for a while with the PowerShell Core project, which is supporting PowerShell running on a variety of different devices. I tried, it didn't work very well. I tried to get PowerShell up and running in WebAssembly. I think it's doable. Don't have it quite there yet, but I think we can run it in the browser even. All right, so the thing though is if the ecosystems are coming together, no one can own that ecosystem, right? If all of the world is coming together, no one can own that ecosystem. It really is going to be community efforts like the group coming together here, or all of these other groups coming together that define what these ecosystems look like. It's not going to be one company, it's not going to be one project, and we see this out in the cloud native open source world today, right? There is a real strong preference both within our customers and within the vendors and everyone else for vendor-neutral open source software that is developed collectively, where there's not a single company that happens to manage a particular tool, and there's not a particular company that happens to be responsible for all pieces of it. And I think that, too, is a really valuable thing, and it's because these systems are becoming so large and so complicated that we can't build them. Like if we all just build in our silos, we're not going to build the systems that we need to build. Right? We need to build that whole ecosystem together in a world where we build the undifferentiated heavy lifting together. And this is especially true, I think, when we start thinking about the world of multi-cloud. I spend most of my life in the cloud, and multi-cloud is a huge part of what we do. Right? Whether it is people who are on-premise and in Azure, whether it's people who are in Azure and in AWS, there is just a strong need for a variety of different reasons for most companies to be present in multiple different places. And the minute they're going to be doing that, they're going to need tools that go everywhere. They're going to need development patterns that go everywhere. They're going to need administration patterns that go everywhere. And that's only going to happen. That only happens via open ecosystems. And I think that's the other piece that I think is a critical part of what the future looks like. It's clear even from PowerShell as well that the future is open source. And it's been blindingly clear in the cloud world for the last decade that the future is open source as well. And again, I think it's because the problems are too hard. We can't solve them by ourselves. We can't solve them with a single opinion. It's also because failure is always happening, right? And if we build monolithic environments, if we build environments that have to hold together, if every piece has to succeed in order for the whole to succeed, it's a horrible way to build reliable software, right? Pieces of what we build are going to fail. And it only works if we can take out that piece that's failed and replace it with something that can be more successful. And I think that is what leads to this idea of polyglot. It's no longer a one-language world out there, whether it comes to scripting, whether it comes to programming languages, whether it comes to whatever it is that you happen to be doing. We have to find the right tools for the job, right? We see a lot of people doing more Rust programming because Rust is a language that can provide some memory safety with performance. But honestly, especially as I've gotten more and more involved in programming in Rust, it's not going to be a language that most people use. It's just too complicated for people to think. It makes you think about too many of the details. So people will be still programming in .NET, and people will still be programming in TypeScript and all of these other languages. We have to be able to choose the right tool for the right job. and be able to bring all of these different tools together. And similarly, I think we have to be building in a modular way, right? We have to be building in terms of pieces that can compose together well. You need to be able to pull, when you look at the kinds of ways that people are stitching together systems that they're deploying to the cloud, they're pulling from a particular storage technology from one project. They're pulling a web serving framework from another project. They're putting these modular pieces together in ways that enable them to achieve what they need to do, but don't make them reliant on any particular solution. And similarly, I see this in our teams, right? When we think about how we develop, the whole idea of a two-pizza team is a very sort of stereotypical idea at this point, but it really is true that we have to be thinking about how we build for agility, and the only way we build for agility, even within the teams that we build, is this modular environment. I think a piece of this also is building for extensibility. And when we think about extensibility, I was just actually talking to the WebAssembly folks that I've been working with about the importance of extensibility as a pressure relief valve for a community. Right? One of the great things that I think PowerShell and other scripting languages have known from the beginning is that they can't do it all themselves. You're going to have modules contributed by a bunch of different people, and they shouldn't have to all be authored in exactly the same way or come through exactly the same, with the exact same set of people committing to them. You have to be able to enable people to just create random stuff and share it without ever talking to you. And if you don't build your tools in an extensible way, that doesn't happen, and you turn into a bottleneck. And so I think that's a huge part of how, if we think about the community and think about the way that we need to build going forward, being extensible is a huge piece of that. And then I think the last piece I want to talk a little bit about was, I'm going to jump forward for a second. I wanted to talk a little bit about where, if you're thinking about getting involved in this community, what should you be doing, right? And the thing I wanted to highlight is this. I think that if we want to do new things, right? If we want to build things that are useful, in my experience anyway, the useful things in the world come from the pain that exists in the world today, right? And so I would encourage everybody who's thinking about wanting to do something new, wanting to add something either to this community or build a bridge into other communities, to figure out, like, what is it that is painful out there that you would like to see fixed? And if you focus on that solution, if you focus on building something that addresses an untapped pain, you'll find people who are interested in helping you. You'll find people who are interested in using what you build. And in finding those people, I think that we will actually build even stronger communities that come together. Similarly, finding the untapped opportunity. I think that there's some really great examples of places where, I mentioned Bash earlier. There's some places where some of the tools that other people use are stuck, frankly. And have not necessarily, when I look at something like PowerShell passing real objects back and forth as opposed to just streams of characters, it's something that I think is stuck in the Unix scripting community for a long time. Not because I think there's particular, I think it's something that nobody thought to mess around with. And I think there's some interesting things that if we think about looking for these kinds of untapped opportunities, looking for places where there's connection points between various communities, good ideas that maybe need to change a little bit in order to fit in with different worlds, we can actually make tremendous impact on that converging ecosystem and on the overall pain that we all feel together. And that leads to my sort of final thing, which is to not be afraid of others. I think that, hopefully you're not. I don't know if you are. I know that in many cases, my teams are, actually, right? Part of it's the sharing thing, taking responsibility. Taking on someone else's code is a scary thing to do. But I wanted to say that, like, all of my experience across this time has shown me that we're better if we come together. We're better if we trust each other's code. We're better if we take a little bit of risk. that something might be buggy, but that we can fix it, than if we try and do it all ourselves. And so that's, I think, where I'm going to stop. I'm a little bit short, but I want to say thank you, thank you, thank you. I hope it was interesting and useful. I have a couple minutes. I'm happy to take questions, or I'm happy to just give you all a little bit of extra time for your break. Thanks, and have a great conference.